Skylar is a maths student and needs to hurry to his first lecture of the day. An app on his phone tells him there is no wind at all, so he grabs his bike and cycles to the EMCS building. There is, however, a major storm of which he was not aware, and that is why he could not reach his lecture on time.
I don't get why my weather app was so wrong about the wind today. There must be a better way to predict the wind velocity. Let's have a look at these predictions and see if I can put my mathematical knowledge into use to improve them.
Skylar wants to investigate how his weather app predicts the wind and where the error is the greatest. From the website of the KNMI, he downloads predictions and measurements of the wind speed and directions of the past 3 years from 2 different stations: Vlissingen, station 310, and The Bild, station 260. Skylar makes a windrows with the quantiles of the wind speed in meters per second per direction. He concludes that the strongest wind comes from the southwest. Now Skylar wants to compare the measurements with the predictions to see whether predictions can be improved.
From the KNMI, I received the predictions of their ECMWF model for the past 3 years. This data consists of 2 different lead times, the lead times of 24 and 144 hours. That is, when the lead time is 24 hours, the prediction is made 24 hours in advance.
In Skylar's plot, the dashed lines show the quantiles of all observed velocities when a specific velocity was predicted.
I have also plotted the frequency of the observed velocities for each predicted velocity. Now we can see that the left side of the graph is much more relevant for us than the right side of the graph. We can also see that for station The Bild, the quantiles mostly lie below the line YSX, which means that the observed velocity was often lower than the predicted velocity. For station 310, it is the other way around. The predictions have a negative bias. Now it's time for some improvement. Let's see how I can use my knowledge of regression to predict the wind speed even better than my weather app.
Better predictions of the wind speed can be made by introducing a multivariate ordinary linear least squares module.
I am now going to test whether the predictions of my new regression model are correct. In this graph, the predictive power of the new model is tested against the models of the KNMI by making use of cross-validation. As you can see, my model produces better results in all situations. I'm curious about the added benefit that each of the input models has for the predictive power of my regression model. To investigate this, I can perform the linear regression with a different set of predictors. If we take a look at the root mean square error of the models with a different amount of predictors, we notice that we're indeed not winning much predictive power by adding so much information to our model. The input models appear to be cross-correlated, as can be seen here. In the old models, we saw a bias. Let's see whether our new model improves this. We see that for velocities that are predicted often, the residual stays centered around 0, which is good because this means there's no bias. If we look at the same graph in the ensemble model, we see that for even the velocities that are predicted often, the residuals skew to the top. This is bad. That means that we systematically underestimate certain velocities. Luckily, our new model corrects this bias.
Skylar also made use of logistic regression to further expand his module. Using bias scores, RSC diagrams, and reliability plots, he proved that his model was indeed better at predicting high velocities than the other models.
Whoa, I'm seriously blown away by these results. My new model works really well. Adding extra data to it, such as the observations of the previous days or making separate models of each season, does not seem to improve the model a lot, if at all.
Now Skylar could finally make his weather app, and he made it just in time because the storm was coming rapidly. He was standing outside when Sunny was running to the EMCS building. He warned her for the storm, and as a thank you she went on a date with him. They fell in love and lived happily ever after.